Hello, this is Vivek Babele again, and today we will discuss about injection molding. So first we will discuss what is injection molding. So injection molding is a manufacturing process for producing parts by injecting materials into a mold. Injection molding can be performed with a host of materials, mainly including metals, glasses, elastomers, confections, and most commonly thermoplastics and thermosetting polymers. Material for the parts is fed into a heated barrel, mixed and forced into a model cavity where it cools and hardens to the configuration of the cavity. This is the injection molding machine. You can see this machine and its parts. Main components of injection molding machines are clamping unit, injection unit, drive unit, mold, hydraulic system, control system, hopper, heaters, and cooling channels. Injection molding process resources are material, machine, mold, and manpower. Most commonly used materials are PVC, that is polyvinyl chloride, ABS, acrylonitrile butadiene styrene, polypropylene, polystyrene, HDPE, high density polyethylene, LDPE, low density polyethylene, rubber thermoplastic, and epoxy resins. Injection molding process is like material preparation, feeding into the hopper, injection, mold, holding and cooling, and ejection. Injection molding machine process starts like that. Material granules are fed into hopper, then melted down in barrel which is surrounded by the heaters. Melted material is injected into mold cavity and mold is held under pressure until the material cools and hardens. Once the material hardens, the mold is opened and the component is ejected by a runner plate, and the process can be repeated. Molds are common terms used to describe the tool used to produce components in molding. Molds are constructed from hardened steel, pre-hardened steel, aluminum, beryllium, copper, alloy. In general, steel molds cost more to construct, but their longer lifespan will offset the higher initial cost over a higher number of parts made before wearing out. The molds can be manufactured either by CNC machining or by using electrical discharge machining processes. Mold design. The mold consists of two primary components, the injection mold A plate and the ejector mold B plate. Mold design considerations are like that. Shrinkage allowances depends on shrinkage property of material core and cavity size. Cooling circuit. In order to reduce the cycle time, water circulates through holes drilled in both and the core and cavity plates. Ejection gap. The gap between the ejector plate face and core back plate face should hold dimension within the core. It must allow component to be fully removed from the mold. Another considerations in mold designing is mold polishing. The core cavity runner and screw should have good surface finish and should be polished along material flow direction. Mold filling. The gate should be placed such that the component is filled from the thicker section to thinner section. Draft required in both the core and cavity for easy ejection of the finished component. Mold storage. Manufacturers go to great lengths to protect custom molds due to their high average cost. The perfect temperature and humidity level is maintained to ensure the longest possible lifespan for each custom mold. Custom molds such as those used for rubber injection molding are stored in temperature and humidity controlled environments to prevent warping. Mold cooling. Constant mold temperature for uniform quality, reduced cycle time for productivity, improved surface finish without defects, long mold life, avoiding warpage by uniform mold surface temperature, warpage caused by non-uniform cooling. Mold cooling will be carried out like that. Molding defects, a blister, flash, burn marks, warping, weld lines, color streaks, and voids. Manpower required to set up process, to monitor process and troubleshoot, to operate machine. Injection molding mainly used for plastic injection molding, rubber injection molding, and metal injection molding. Plastic injection molding is a manufacturing process for producing components by injection polymer material into a mold. Thermoplastic and thermosetting plastic materials are used. Thermoplastic materials are reusable. Plastic injection molding materials are like that. Plastic injection molding applications: writing instruments components like pen barrel, cap, bush, etc., computer electronics, automotive components, aerospace components, electronic components, toys, etc. Rubber injection molds can make many rubber components. It makes valves, steam seals, oil seals for engines, telecommunication items, etc. Metal injection molds can stamp out small to large items. It can stamp out automobile parts from spark plugs and floor pans to ball bearings. It also can stamp out items like TV hangers and knitting needles. Advantages of injection moldings are fast production, low labor costs, design flexibility, high output production, multiple materials can be used at the same time, can be used to produce very small parts, leaves little post production scrap, ability to include inserts, good color control, good product consistency, reduced requirements for finishing, good dimensional control. Disadvantages of injection molding is high initial tooling and machinery cost, part design restrictions, small runs of parts can be costly. Applications of injection molding is used to create many things such as cups, containers, tools, mechanical parts, including gears. Injection molding is the most common modern method of manufacturing parts. It is ideal for producing high volumes of the same object. Thank you very much. Please like.